All right, welcome to our study of how to classify matter. Make sure you're filling in the blanks. And we talked in class that matter is anything that has mass and takes up space. So we're going to pretend you have found something new. You don't know what it is. So the first question as a chemist that you would ask is, what type of matter are you working with? We're going to separate matter into two main categories, and those categories are pure substances or mixtures. The difference between a pure substance and a mixture: pure substances have a fixed composition. You cannot break them apart and still call them the same thing. Water is a pure substance. If I break it apart, so water is made of hydrogen bonded to oxygen. If I try to break water apart, I can't call it water anymore. I would have to call it hydrogen and then oxygen. If you have a mixture of something, you can break it apart. So this is a mixture of bromine in water, and I can break it apart, and this is still water and this is still bromine. So I'll get into the detail here, but easiest things to know is pure matter. If you cut it up, you have to call it something else. Mixtures, if you change the ratio or change how many bromine or water are there, you can still call it a mixture. So pure substances, number one, are they on the periodic table? So if I give you a substance like carbon, you'll look at your, you'll look at your periodic table. If it's on the periodic table, it's a pure substance. We'll talk more about atoms later, but they are defined by the number of protons. For right now, just know that if it's on the periodic table, it is pure. And they can look different. This blob of coal here is solid carbon. This diamond is solid carbon. The diamond is carbon that's been under lots of pressure, and it gets pushed into this crystalline form. This lump of coal was, yes, under pressure, but not a lot of pressure, so it never turned into a diamond. So if you want to give somebody a diamond someday, just give them a lump of coal and say, just wait a while, maybe you'll get lucky. Anyway, okay, the other type of pure substance would be a compound or molecule. They have chemical formulas. So again, this is topics for later in the year, but if it has a chemical formula, so you see the symbol of it and maybe a little number next to it, you know that it is chemically combined. The words compound and molecule are loosely used. I would like for you to know the difference. Molecules mean an atom bonded to itself or another atom of the same element. A compound has atoms of two different elements. So oxygen, when it bonds to itself, is an oxygen molecule. Carbon dioxide is a compound of carbon dioxide. I won't be super picky, but I do think you should know the difference to be a chemistry student. All right, so let's look at these formulas. Again, they have to have an exact ratio. So water is made of two hydrogens and one oxygen. Hydrogen peroxide, all we've done is add an extra oxygen, and it makes a completely different substance. So test question right here: when you chemically combine something and turn it into a compound or molecule, it will have different properties than the individual element that makes it. So water versus hydrogen peroxide. Water you can't live without. If you guzzle a glass of hydrogen peroxide and they both look the same, you wouldn't be able to tell the difference. But if you drank a glass of this, you would die. Another example, sodium is on the periodic table. It reacts violently with water. You throw a piece of sodium in water and it will ignite. Chlorine is on the periodic table, a pure substance. If you breathe in chlorine gas, you will die. But you chemically combine them, turn them into the compound sodium chloride, that is table salt. You can't live without salt. We have to have salt in our bodies to balance electrolytes and to help our nervous system work, and you'll learn about that next year. But the whole point here is sodium has properties, chlorine has properties. When you combine them, they become extremely different. So all you have to know though is if you see it on the periodic table, it's an element. If it has a formula, it is a compound, and those are pure. You cannot break them into smaller parts and still call them the same thing. All right, the other section of dividing matter would be mixtures. Mixtures can have varying ratios. So this is a mixture of sand and water. It doesn't matter how much water is there, how much sand. I'm going to call it sand and water if there's 2 grains of sand or a million grains of sand in this beaker of water. So any ratio is fine. They're not chemically combined, which means we can separate them with physical means. So how do I separate something physically? The first way is filtering. So you filter it, particles move through whatever filter device you're using by size. So this is a piece of paper in here like a coffee filter. The water goes right through, the larger grains stay up above. So we separated that without doing a chemical reaction. We know that we had a mixture. The other way to separate mixtures would be magnets. So sulfur's on the periodic table, iron's on the periodic table. When you mix them together, there's no chemical reaction. You just stir them up. You can separate them very easily. And the third way to separate things physically is with distillation. Distillation is using evaporation or the boiling point of a substance to separate it. So it's a great way to purify water, and we will do this in class eventually. We have a solution here of salt water. So imagine this is some ocean water here, and you would like to drink it. You're going to evaporate it. So boil it, the water will evaporate, it will cool down this tube, eventually turn back into a liquid form. You can drink this water, and all the junk that was in the water is here. And this is a physical process. Changing the state of matter of something is a physical change. So filtering, magnets, distillation is how you know you have a mixture. Recap right here if you want to pause. So let's go under that topic of mixture, and we're going to separate it again. So we have pure substances. Pure substances are elements or compounds. We have mixtures. Mixtures you can change up, but then we have two types of mixtures. The first type is homogeneous. The prefix homo means the same. Geneous is an unknown. It's pronounced homogeneous altogether. Homogeneous mixtures look the same. They're one color because they're made of really small pieces. Coffee is one color, wine is one color. The particles are so small in there, you can't tell them apart. So we call liquid mixtures that are homogeneous solutions. But if I froze this coffee or turned this wine into a solid, it would still be a mixture, just a different state of matter. So metals that have been stirred together. So if I melt copper and copper and zinc, stir it up in a pot and let it cool, it is a mixture that looks one color, so it's a solution, but now I've cooled it down and we call it brass. Metals that become mixtures are called alloys. We will actually make brass in a lab pretty soon here. So one color looks like it would be a solution, but it's not because it is made of two things mixed together. The best way to tell if you have a solution, if you shine a laser beam through liquid solutions, the light will go straight through, and I'll show you that in class. So light moves through solutions. Okay, the other type of mixture is heterogeneous. Hetero means different, geneous is unknown. That just means they have very different and visible chunks. So a homogeneous mixture is made of different things also. It's called homogeneous because it looks like it's all one thing. Heterogeneous actually look different. There are two types of heterogeneous mixtures. The first one is a colloid. Colloids are usually liquids that are one color. It's easy to confuse them with a solution, but they have bigger chunks and light can't go through. If you try to shine a laser beam through a cup of milk or shine your lights in fog, the light goes in all different directions, and that is because the chunks that are floating in here are bigger. But they're tiny enough that they stay mixed in. It looks like a solution. So we'll look at colloids. This is the hardest one to figure out. It's usually thick liquids. Thick liquids, fogs, clouds is a fog on the ground. Those are types of colloids. So they look like they should be a solution, but they're thick is kind of the distinction. The other type of heterogeneous mixture is a suspension. I think of this like suspenders hold your pants up. Suspensions have bigger chunks that are held up but will fall down, just like your pants will fall down. So suspensions are very easy to identify because you can see big chunks in there. Colloids are more difficult. You can't see the chunks, but there are chunks of protein and fat floating around in this cup of milk. They're just too small for us to see, but we know they're there because the light won't go through. So heterogeneous, bigger chunks. Colloids are going to be those liquids that are one color. Suspensions are usually a liquid mixed with a chunky solid. And that is the end of our Types of Matter lecture. We'll do a lab on this and a worksheet and hopefully get it all in your head.